Okay, here we have problem number 55. In this problem we have 25 kilogram block is initially at rest on a horizontal surface. A horizontal force of 75 Newton is required to set the block in motion, after which a horizontal force of 60 Newton is required to keep the block moving with constant speed. Now in part A we have to find the coefficient of static friction, and part B coefficient of kinetic friction between the block and the surface. Now for this one, let's draw a free body diagram for the block. Suppose we have a block, okay, it's on a rough surface. So we have here applied force. So this is a force which, when it's applied, so that force is 75 Newton, which requires to start the motion. Okay, then here we have a normal force. Okay, normal force. Then here we have a friction force. Now this friction force can be static or kinetic depending on the situation. Now first of all, we know that in the part A we have to find a static friction, okay? Then here we have one more force, which is Fg equal to mg. Now the mass is given, which is 25 kilogram. Now if we want to find the static friction, then these forces, static friction and applied force, has to be equal. Okay, if that's equal, then we also know that formula for the static friction is equal mu static multiplied to the normal force. Now we also know that normal force is equal to mg, so that means we can say mu s mg. Now then that's equal to applied force, which is equal to 75 Newton. So finally we just have to find mu s, which is F applied divided by mg. And if you plug the numbers, 75 Newton divided mass is 25 multiplied 9.8 and so on. So if you do calculation, you can find that 75 divided 25, okay, 75 divided 25 times 9.8, which is equal to 0.306. Okay, now what about the part B? Now in part B, now once the block is started moving, then you just need 60 Newton in order to keep the motion in a constant speed. Okay, in that case you have to apply kinetic friction, which means F kinetic friction is equal to F applied. So the same things, except mu s you have to apply mu k. So mu k is equal, mu k times n can give you Fk, which is equal to F applied. So from here, mu k is simply equal to F applied divided by mg. So here is 60 divided 25 times 9.8. So 60 25 times 9.8, which gives you 0.245. Okay, this is how you solve such a problem.